When it comes to performance, there is one technique that governs all of computing. Without it, your computer basically would not exist or work at all. I'm Joanna Smith, and caching is as fundamental to performance as it is to the design of the hardware in the phone that you're holding. If you think about it, there's a pretty clear reason why computers have RAM. It acts as a data cache to access recent information fast, like super fast, compared to having to get it from the hard drive. And this is basically what a cache is, a place to store data that's frequently used so that future uses happen as fast as possible. Anytime that you have an overhead cost for computing a piece of data, or loading it, or finding it, a cache can help you do it faster and more effectively the second time, and the third time, and you get the idea. So, in your app, the most common place where you can win with caching is when you have data that is calculated multiple times, but the result is always the same. No one would ever argue to move non-variable work into an inner loop, but it may surprise you how easy it is to do this by mistake. Consider a simple example where you're calculating the derivative of a 4x4 matrix to use when calculating your loop control variable. But that matrix never changes within the loop, so you're actually wasting performance recomputing the derivative on each iteration. Instead, compute and save the result outside of the loop and let the inner portions of your loop reference that cached result. This may sound obvious when presented like this, but you would be surprised how even seasoned developers get caught by it. Like when calling getCurrentUser inside of a loop in a single user environment, like a mobile game. Caching also acts as a fantastic resource for limited resource environments. For example, let's say that you have about 2 gigabytes of images that the user might need to display, but you can only fit 50 megabytes of them in memory at a time. So the Android framework will help you out as much as it can if you use an adapter view. But you can make this more effective by keeping track of what images to keep in memory and which to evict, so that the framework doesn't need to evaluate the full 2 gigabytes of content. Then, there is the less common form of caching known as pre-computation. This is essentially where you spend time offline to calculate a huge lookup table or a massive XML schema, so that at runtime you can simply fetch that data rather than executing all that expensive overhead while your user is waiting. And that's the whole point, avoiding unnecessary work. So if you're looking to make performance improvements or trying to build a new app that's already perfect, take a pass through places where you loop or load data or have heavy computation and see what you can shift around. Also, avoiding unnecessary work is pretty much all we talk about in the rest of the Android Performance Patterns content and in our G+ community, which is why you should check both of them out. So keep calm, profile your code, and always remember, perf matters.